So myself is Ambika Singh. I work at Cotiviti, Nepal as a principal software engineering. So let's begin our presentation on 7 testing principles. So this slide is regarding about myself. Let's begin. For today's presentation, these are the few agendas which I'll be covering. For example, first topic will be a few misconceptions regarding testings, and next is what is testing. Next is typically objectives of testing, and next the testing contributes to success, 7 testing principles, and last one is risk-based testings. So as we do the QA, as we start testing, everyone thinks that there is misconception regarding the testings. Everyone thinks that we as a testing or tester just do the test case execution. They don't do much thing. They just write test case and just execute test case. Also, some people also believe that the testing is just all about breaking the software. They don't do much. They just try to break the system. And also some few also think that testing can find all the bugs. People think that once the testing is done, there is no bug at all in the software. The tester finds all the bugs. This is also another misconceptions on testing. Next one is that it does not work in if any software is not working in production, that means the tester didn't do testing correctly, tester failed. That's also another misconception. So that I think as a QA member or as a tester, we all have faced these misconception regarding while working in our workplaces. And next one is also that testing can be automated. Everyone thinks that a tester can automate every test cases and then perform. They don't have to do much more. And next one is testing happens at the end. Testing doesn't start from beginning, but it's also happens at the end. That's also another misconception in testing. Let's start. What's the testing is? Everyone thinks that testing just means test the application. That's all. But generally, we can say that actually speaking, testing is just not about the to test. It's the way to assure that the quality of software and to reduce the risk of software failing in operation. Next, we can define testing as the process of evaluating a system with the intent to find whether it satisfies the requirement or not, what the client has required for it satisfy or not. In another word, we can say the testing is means executing a system in order to find any gap or any error or missing requirement in contradict to the actual requirement. Also, we can define testing. We can say that the testing means maintaining the quality of the product. Testing is all about maintaining the quality of the product to try to find that much bugs possible. And next one is that the testing has its own life cycle, and each life cycle has focuses on the quality only, nothing else. Just focus on the quality and all. Let's go to the next slide. Next slide is about objective of testing. As we define testing, there are some objectives of the testing as well. We can say the first testing objective is that to prevent the defects. Uh, Talking about the preventing defect means we can start testing earlier as possible. We can start testing in requirement. Also, we can find defects if we are involved in requirement collections. So at that time also we can find defects and prevent that. So first one is to prevent defects. Next one is to evaluate work product. And work product means we can be involved in, sorry. We can, if we involved in the work product, like in the gathering of requirement, we can take the part in discussion and we try to understand what the exact requirement is. And next objective is to verify the requirement. And similarly, following with the validate test object, try to build the confidence of our product. Next one is to reduce the risk. Similarly, follows with the share information to stakeholder. Try to share the information to the stakeholder. Next one to find failures and the defects. That's these are the few testing objectives. Let's move to the next slide. That's about testing contributes to success. As we know that if proper testing is not done, then the development we will deliver with the low quality product. There will be many defects in the product or system. So it's very important to test the application properly with the proper guidance and with the proper test cases and the proper level of the testings. So it's very necessary to follow the each life cycle of testing development, and so that we can prevent defects as many as possible, and we can deliver quality product. So for contributing to the quality product, we can take examples like, so when testers are involved in requirement reviewing or story refinement, that time also we tester can detect or defects in this work product and identify, and after detecting the defects, it will help to removal of the requirement defects, and it will reduce the risk of incorrect or instability features being developed, and it will also be it will also to prevent to cost cutting and all. Next one is to having tester work closely with the system designer. So while working with the system designer, it will help us and as all the team member to understand the how designs are working and how the it will be designed and how we can test it, and it will also reduce the fundamental design defects and enable tester to identify as early as possible. So later will be these defects will later not find, so it will find earlier as possible. Similarly, other example we can test that the having tester verify and validate the software prior to release can detect failures, and this will encourage the likelihood that the software meets stakeholder needs and satisfy requirements. These are the few points which will help the contributing the success of quality products or quality software. So moving forward, it's the main topic of our presentation, seven testing principles. It's very difficult to actually in this agile framework or agile sprints, we have very limited times. In that limited framework time, it's very difficult to what to test, what to not test, and in that constant time framework, it's very doubtful to cover every and to cover each and every features and find defects very in short period of time. So it is very important that we should achieve our goal or testing results conducting software testing with the without deviating from the goal. So for that we determine these seven testing principles. So we should use this seven testing principles, so it will help us to find the bugs and release the quality product. For that we need to align with the seven testing principles. So let's go for what are the seven principles. Seven principles. First principle is that it says that testing shows the presence of defect. Next one is executive testing is impossible. Next, third one is early testing, and fourth one is defect clustering. Fifth one is pesticide paradox. Next one is testing is context dependence, and last one is absence of error fallacy. These are the seven testing principles which we should understand and we should implement while doing any testing or executing any test case or executing for software deployment in production or QA environment. Let's go one by one for these all seven principles. First one by name, it also says testing shows the testing shows the presence of defect. It doesn't mean that there is absence of defect. Usually, while after testing any software, people thinks that this software is defect free. There is no any bug or issue. It is 100% tested, so it's there is no any presence of a defect. So testing will show that the defect are present in the software, but it will never show that the product is defect free. It will never claim for a software that my software is 100% defect free. It will always have some failure or some issues which are unknown to for us. So we can say that testing shows the presence of defect, not their absence. Testing can also show that defects are present but cannot prove that there are no defect. Testing reduces the probability of undiscovered defects remaining in the software, but it will not show that the product is 100% defect free. Also, another we can say that testing is not done for prove that the software is bug free. It's just the quality. There is no much defect, but the quality is there with the testing. For example, we can take that when the software tester is testing any Android application, he should be working hard to identify potential defect rather than proving that the product is defect free. This will help him to identify more defect rather than the achieving correctness. So it's all means that the defect, if there is no any defect, it does not mean that our product is defect free. It's just says that there is still some bugs are present which are not visible, but the quality is there. Major defects are there, not presence. Let's go to the second testing principle. It's also the exhaustive testing is impossible. By name itself, exhausting means testing the application. It's not possible to test the application in all combination and all precondition. It's very time consuming and also costly to test in each and every scenario. So instead, we can say that we need to test based on the risk assessment of the application. What are the major feature or what are the major things we need to test, and accordingly we need to test. We don't need to we can't test all combination. It's very time consuming. So it's better way to test in a smarter way, adopting in order to complete the timelines. And we also need to prioritize what's need to be tested on the basis of risk. For example, we can say that assume there are testing the email subscription feature for an application, and there are thousands users subscribed. And while testing email subscription, working for 1,000 emails consumes a lot of time and cost. For this, we can instead identify, sample, or prioritize the important test based on the requirement, and we can test accordingly. We don't need to test in every combinations. So for this, there are few strategies that we can do while attempting for the existing testing. First one is to focus testing. We can focus and prioritize critical and crucial tested scenarios by means of automating testings. Next one is the probability of failure. So first we need to importantly decide what parameters are important or functionality has greater risks of failure. And accordingly, we need to test that feature first. Next one is regression testing. Tester should identify which unit get impacted the most, and when any changes is made on that application under test, regression testing over those part becomes more important. Next one is early testing. Early by name it's suggest we must test the early testing. We start the testing earlier as possible. We just no need to sit and wait when the developer will develop the application and or product, and when they will hand over, and then only we can start testing. It's not that as possible as possible we need to start early testing. Like we can start testing while gathering requirement or designing. And so tester should start early testing, so it will find more defects earlier rather than the late at the end of the development. So early testing will help us to find. Early testing should we need to do static and dynamic, both activities should be started as early as possible in the software development life cycle. And early testing is also sometimes referred as the shift lifter. That means we can start our testing at the starting, at the time of requirement collecting or during the requirement review. So it will help in the software development to reduce or eliminate the costly changes. Software testing starts from requirement gathering. It's already mentioned here. I have talked earlier as well. So testing should be done parallelly along with the other product development phases like requirement gathering, designing, while development also. We can do our testing from our side as well. So finding defects early will save a lot of money and rework time as well. For example, we can that consider product requirement gather is completed and developer start coding. Once the development is done, tester identifies a defect in the requirement gathering and found that that the requirement should be changed. This cost lots of money and time loss for the company, and also finally end up in reworking. Instead, it would be find earlier on that could have saved the company a lot of money and time. If tester would have involved earlier in requirement gathering, then this time would be had been minimized and defect would be removed earlier in the requirement gathering only. This is the third principle. Fourth one is the defect clustering. It with the name only we can say that the small, if we find many bugs in any one or two modules, the majority of the bug will be contained in that module only. So it by name only we can say the most of the defect, if you find in one module, most of the defect will be in related to that module only, not the other modules. So a small number of modules usually contains most of the defects discovered during pre-release testing, or it is responsible for the most of the operational failure. And predicted defect cluster and the actual observed defect cluster in the test or operation are important input into a risk analysis used to focus the test effort. Defects are not necessarily spread even. They may have clustered in one or few modules, and place where one bug are found likely to find more bugs in that module only. So it is like 80-20 principle. If 20% of bug will cause the 80% of problem, assume that if new program has developed complex module, then it is very likely to find more defect in that particular modules rather than the other simple modules. By next principle is the pesticide paradox. By name, it's we can say that in agriculture also, when we use same pesticide again and again in the crops, so at the some point or particular time, that pesticide will stop working, that pest, because that pest will start to build immunity power against that pesticide. So that pesticide will stop working on that pest. So similarly, in the case of testing, when we'll execute same test case again and again, we'll not able to find new bugs or new defects. So time and again, we need to change that test cases according to the requirement or according to the changes we got. So executing same test cases will not help us to identify new bug at all. So to to detect any new bug or find any new bug, we need to the existing test case needs to be changed, and new test cases should need to be added or returned so that we will able to find new bug accordingly. And to cover up these, to find new bug, it's very important to review our test cases regularly or modify them if required. And different and new test cases should be added to find more defects in the software. So example, we can see that executing functional test case again will not help to identify neither defect regarding the performance of the system nor the defect regarding the security threat. So our test cases should be different to potentially identify new defects. Next one is that our testing is context dependent. So testing is done differently in different context. For example, if safety critical industry control software is tested differently from an e-commerce mobile app. Another example, we can say that the testing in Agile project is done differently than the testing in sequential software development lifecycle. So we can say that testing is always context dependent. It is not, we cannot execute same test case in every environment. So software should be tested based on the purpose of the product and that has been built. And we can say example, the banking software cannot be tested same as the e-commercial and functionality, because the functionality of both the product are different. So obviously we need to test accordingly those two different. For example, we can say that the banking software have functionality like transaction, interest, and saving, etc. An e-commercial site have some features like shopping cart, order, payment, etc. So both are completely different in their functionality. So scenario for the testing for these two applications should be different. We can test with the same test cases with these two applications. So our sixth was the testing is the context dependent. Next 7 is that the absence of error policy. Always people think that when the testing is done, that means it's very rare to find defects. So our tested software is error free. So some organization accept that when the tester had run all the possible test cases or find all the defect, that means our software is error free. But our principle 2 and 1 already describe that our software is never error free. It has some defect which are unknown, and existence testing is it's impossible. So we can't say that there is absence of error is policy. Furthermore, it is a mistaken belief to accept that the just finding and fixing large number of defect will never ensure that our system is successful or it's error free. For example, we have tested, we can say that we have tested all the requirement, specified requirement, and find all the bugs, and we have also fixed all the bugs, but it does not fulfill the user needs and expectations. So that it's very, we cannot say that it's a complete solution. So it's always we can next one is that the finding and fixing defect does not help if the product software fails to meet user requirement. uh, Testing design should cut most defects and also should cover all clients requirement, especially before shipping the product. Example, we can say that the software tester completely tests the product and the software is 100% defect free. Is that mean the product is ready to ship? No, we can say that the software tester should be verify the test design, cover the customer requirement and specification. If the build software fails to meet requirement, then the finding and fixing bug does not really help. That all means that the requirement main we are giving this all to the customer, so we should test that the it's meets the customer requirement and specification, then only we can say that it's done, we can ship the product. These are the 7 testing principles that I have covered, and there is also me that these are just principle, these are for the reference, I will not use them in the practical. This is very untrue. Actually, this principle will help us to identify and defects earlier, and also helps to execute test case in the effective test strategy, and helps us to build the effective test strategy and draft error causing test cases. So we can't just say that these principles are just for the uh, just for reference. We can implement these principle, and we can do our testing, so we will find most of the defects in on time, and we can release quality products. um, is there any questions regarding these 7 testing principles? Are everyone understanding what I'm saying, or just I am? Oh, there is one.
Yes. So you told about the regression testing, right? So among these 7 principles, in which principle the regression testing is applied, and what steps should be done for the QA to not to repeat again the test cases which has been tested on the sprint planning.
Uh, Regression testing can be covered in any of the, we can say, in any principle it can be fitted, but regression testing is done when there is changes in requirement. When we change in any module, then we should be sure that the previously working features are not broken. So once we need to just thoroughly check, do regression testing. After that, fixed has been done. Is my question, is your question answered?
Yeah. Yeah. Thank you for that one. And another question is about the technical depth versus cultural depth, right? So based on this 7 principle, most of the company runs on the cultural point of view, right? So there might be some
Yeah.
technical depth there might be low quality of standard, right? No standard practice. So how this 7 principle will help on that part, the cultural depth and versus the technical depth on that side.
Yeah, regarding that, so testers should be included when we say that the cultural versus the technical. Tester usually when we do technical, people say why tester should be involved. That's the first. It will bug will leak there when testers are involved earlier as possible, like when they are doing dev technical, it's not necessary the tester should be included in every dev we are doing. When you all are doing dev technical to dev technical, that's not the part, but brief technical, how we are going to implement, what are the technical challenges, in that tester should be involved, so that they will we know how these software are developed and how they are going to test it, and so that they will find out the steps to what need to be test first, and they will write test cases accordingly, and which part is more important and which one is not that important, I mean to say which one is more risky and which one is less risky. So we need to cover more risky part as earlier as possible, so that we can identify defects while doing technical discussion only. Is this achievable or not? If this is achievable, then how user are going to react, how user can use it. If this type of in this type of discussion they are included, testers are involved, and this earlier defect will be finded, and this can be fixed initially in the requirement gathering or requirement reviewing only, and this type of removal will help company as well as the PO or BO to eliminate that risk when they will find at the end of the development, when we developed and oh, this is the requirement bug, and then the whole process need to be done again, which is time costly also, and it's timely also. We need to rework on that product. So it's basically we need to, yeah, initially it will be very difficult to involve in, but try to involve QA in each discussion, in not in depth technical, but initially depth in how we are going to implement and how what are the features we need to test. These are the important features and this is the risk, so they will know the what in what are the scenario what we need to test it, and it will help to identify bugs and eliminate that bugs. Is your question answered? So I was so interested in this topic, so I included in my slides, but it's out of the seven principle. My this topic is regarding risk-based testing. Usually, I try to include this topic just because when I used to work, when I started my career as a QA or software quality insurance, it was very difficult to find out what to test, and we had also very in agile sprint we have couple of weeks, it's just 2 weeks, and in that time frame we don't have that much enough time to test each and every features, and as development progressed the software becomes more complex, requirements requires more time to verify its functionality, and running thousands of test cases it was not feasible in that 2 weeks of times. So tester needs to prioritize or find what needs to test first in that short period of time. So just while doing that, it answered that risk-based testing it should be done. We need to find actually which part is got risk, most risk. So we should test that part. So risk-based test approaches organize testing efforts in a way that lower the residual level of product risk, and when the software goes into production, and that means it will lower the error, it will minimize the getting error while we release our product in the production. So it will earlier defect will be covered earlier, and how we are going to, so this risk-based testing should be adopted while doing testing in our agile sprints or that's so this strategy is very useful to test analysis, planning, estimation, design, execution, and result reporting. So before creating these plans, it's very necessary, so we need to ask these following 5 questions, like what need to be tested first, how to reduce the testing effort, how many feature can be covered with each test cycle, how to decide what not to test, and what metrics are required to measure testing success here. These are few questions we need to discuss and finalize the answers. So next is the purpose of test-based risking. Why it's testing, risk-based testing is important. Here are some few what M's or principles that is applied for risk-based testing. So creating and offer a framework that facilitates clear discussion between tester, developer, and other stakeholders about the risk at hand. And essentially, it isolates risk to make them identifiable and actionable, and cover customer needs as well as developer needs when considering what counts as a risk, and provides the criteria or to decide how to manage budget, negotiate timeline, avoid delay, all without affecting software quality, and highlights what feature or issue matter most to clients, thus creating a hierarchy of testing requirements. These are some principle of risk management testings. Next one is level of impact. So we can identify the risk impact. So is the risk critical or medium or moderate or marginal? So accordingly we can, this level of risk are there are four levels of impacts: so critical, medium, or moderate, and accordingly we can define that risk is critical or medium, and accordingly we can test the our product. Next one is the matrix. So what are, there are some essential metrics for risk-based testing, like number of test cases planned versus executed, and number of test cases passed versus failed, number of risk identified, and status and severity of each, number of critical risk still open, and instance of test environment downtime, and test summary report, test coverage report, effort expanded, schedule versus actual, schedule variation, plan versus actual, and percentage of risk identification, percentage of risk mitigation, and percentage of defect leakage. These are some of metrics which will help us to risk-based testings. This is all for my presentation. Thank you.